Welcome back for another deep dive. Today we're going to be looking at a paper all about learnable digital twins, LDTs for short, for wireless networks.
Okay.
Imagine you're a researcher trying to figure out how your network's going to perform with like different setups. But running those simulations takes forever.
Right.
That's where Glance comes in.
Okay.
It's an LDT that learns from the simulations offline and can predict network performance super fast.
Interesting.
So we're going to unpack how it works and why it's such a game changer,
Right.
especially for our listeners out there who are familiar with NS3,
Okay.
but want to really supercharge their research.
That's a great way to put it. Think of Glance as like your AI assistant for network research.
Okay.
You get insights in a fraction of the time.
All right, so let's set the stage here. We all know traditional network simulators like NS3.
Yeah.
They're powerful tools,
They are.
but they can be painfully slow.
Oh, absolutely.
Right.
Researchers spend so much time waiting for simulations to finish.
Yeah.
Especially when they're exploring all these different configurations.
Exactly, and that's where LDTs come in.
Okay.
They learn from these really time-consuming simulations offline,
Right.
and then use that knowledge to predict network performance in real time.
Interesting.
Pretty neat, huh?
Very, very clever.
So the specific LDT we're diving into today is called GLANCE, which stands for Graph Enhanced Learning Architecture, featuring network embeddings for communication network evaluation.
Wow.
It's a mouthful, I know.
Yeah.
But
Catchy though.
it's basically like a superpowered GNN or graph neural network.
Right.
Specifically designed for wireless networks.
And the beauty of Glance is it's not just some, theoretical thing.
Right.
The research shows that it can accurately predict these key performance indicators or KPIs,
Yeah, okay.
like delay, jitter, throughput, and packet drops.
Right.
Those are the metrics that tell you like how well a network is actually performing.
Those KPIs are crucial.
They're like the vital signs of a network.
Exactly.
So before we get too deep into how Glance works, let's take a step back and think about like why this kind of speed and accuracy
Right.
is so important for researchers.
So imagine you're trying to optimize a wireless network, right?
Okay.
You might want to tweak things like data routing, the traffic loads, or even where the nodes are placed.
Yeah.
Traditionally, you would have to run countless simulations in like NS3 to see how each change would impact things, which could take days or even weeks.
Talk about a research bottleneck.
Exactly. But with Glance, you can test those changes basically instantly.
Wow.
It's like having a crystal ball that shows you how your network will behave with these different setups.
That's pretty amazing.
It is.
So?
This means faster design cycles, more efficient research,
Yeah.
and in the end, better wireless networks.
Okay, so we've established that LDTs like Glance can be really revolutionary.
But how does this magic actually work? Let's peek under the hood.
Okay, so imagine Glance as like a black box. You feed it information about the network, such as the topology, which is kind of like a map of how all the devices are connected.
All right.
You also tell it about the flow definitions, which basically say where the data is going, and the traffic patterns, which describe like how much data is flowing at any given time.
So it's like we're giving Glance a blueprint of the network.
Yeah.
And then telling it how we want the data to move around.
Exactly.
I like that analogy.
And based on this information, Glance can predict those really important KPIs that we mentioned before.
Yeah.
Essentially, it's learning how the network behaves in these different conditions.
Now, you mentioned earlier that Glance uses GNNs.
Right.
Which are really good at understanding the relationships within a network.
Exactly.
But what's so special about the way Glance uses them?
This is where things get really cool. Glance goes beyond these basic GNNs. It's got this unique 3-subnet architecture that lets it capture these like complexities of wireless networks.
3 subnets?
Yeah.
Okay, I'm intrigued. Tell me more.
So we've got the path subnet, the link subnet, and the node subnet.
Right.
Each subnet focuses on a different aspect of how the network's behaving.
So it's like a 3-pronged approach to understanding like the network dynamics.
Exactly. So think about it. In a wireless network, data packets travel along specific paths, right?
Right. like cars on a highway.
Perfect analogy.
Okay.
The path subnet focuses on that journey that the data packets take.
Okay.
It uses these special neural network units called GRUs,
Right.
which are really great at processing sequential data to track the path of the packets as they're hopping from one node to another.
So it's not just looking at the individual links.
Right.
It's considering the entire route that the data takes.
Exactly.
Okay.
Now remember that multiple paths might share the same link, right?
Right, like multiple cars merging into the same link.
Exactly. That's where the link subnet comes in.
Okay, I see. So the link subnet is all about how those shared resources affect the performance of the network.
Exactly. It uses what are called multi-layer perceptrons, or MLPs, to refine its understanding of each link,
Right.
taking into account the traffic load and the congestion that might happen when multiple paths come together.
Pretty clever.
It is.
And what about the node subnet, that third one?
This is where Glancy's understanding of the wireless dynamics really shines.
Okay.
It uses a technique called edge graph convolution,
Okay.
which lets it process information about each node, while also taking into account interference from neighboring nodes.
Because in a wireless network, devices can interfere with each other's signals.
Exactly.
Okay.
That's something traditional simulators often have a tough time modeling accurately.
Right, it's like when your Wi-Fi gets slow because your neighbor is using the same channel.
Exactly.
Yeah.
Glance, with its node subnet, can actually learn how those interferences impact network performance.
Wow, so Glance is really getting into the nitty-gritty of wireless communication.
Yeah.
It's not just a simplified model. It's capturing these nuances of how these networks actually work.
Exactly. And that's a big reason why it's so accurate and efficient.
So we've covered the three subnets. Is there anything else about Glance's architecture that we should know about?
Yeah, one more key point. Glances is differentiable with respect to traffic patterns.
Okay, I have to admit that sounds a little intimidating.
Yeah.
Can you break that down for me?
Sure. So in simple terms, it basically means that we can use calculus to understand how changes in traffic patterns will affect those KPIs that we talked about earlier.
Right.
It's not just predicting what's going to happen. It's giving us the tools to figure out why it's happening.
Oh, so it's like having a deeper level of insight into how the network behaves.
Exactly.
Not just the what, but the why.
Exactly. And this opens up the possibility of not just predicting how the network's going to perform, but actually optimizing it.
So we could use Glance to actively manage the network, not just analyze it.
Absolutely. And that's actually what we're going to be exploring in the next part of our deep dive.
Okay.
We're going to look at how Glance can be used for things like traffic load optimization and flow destination selection.
All right, I'm already hooked. Let's dive into those applications.
Sounds good. So let's talk about how we can actually use Glance to make wireless networks better.
This is what I've been waiting for.
Right.
We've heard all about how it works, but now I want to know how we can use it to solve real problems.
Exactly.
So the paper talks about two main applications.
Okay.
Traffic load optimization and flow destination selection. So let's start with traffic load optimization. What exactly does that mean?
So think of it this way. You have a network with limited capacity.
Okay.
And you've got all this data trying to flow through it.
Like rush hour traffic, but on the internet superhighway.
Yeah, exactly.
All right.
Traffic load optimization is all about adjusting how much data is flowing through different parts of the network to prevent congestion and keep things running smoothly.
So instead of just letting all that data flood the network and cause traffic jams, we're using Glance to intelligently manage the flow.
Exactly. Glance can analyze the network topology, the traffic patterns, and those KPIs that we talked about.
Right.
And then it figures out the best way to distribute that data load.
It sounds incredibly useful.
It is.
I mean, who hasn't experienced, lag or buffering because of network congestion?
It's a really common problem.
Yeah.
And Glance offers a really powerful solution.
Okay.
So by dynamically adjusting those traffic loads, it can help make sure you have consistent performance.
Even when demand is really high.
So imagine you're streaming a movie.
Yeah.
And suddenly everyone in your house starts using the internet.
Right.
With Glances, your movie just keeps playing smoothly.
Exactly.
Because it's intelligently directing that traffic behind the scenes.
It's like having a traffic controller for your data.
I like it.
Making sure everything is flowing efficiently.
Okay, that's traffic load optimization. What about flow destination selection?
So sometimes it's not just about how much data is flowing,
but
also where it's going.
I see. So it's like we're choosing the best route
Exactly.
for our data packets to take.
Flow destination selection is about deciding which nodes in the network should be getting the data
Okay.
to get the best performance.
So instead of just like sending all the data to one central location,
Right.
we're using Glance to distribute it strategically across the network.
Exactly. Think of it like this, right?
Yeah.
You have a big office building
Okay.
with tons of employees.
All trying to use the internet at the same time.
I can picture that.
So instead of having all that traffic going through just one main router.
Right, which could get overloaded.
Exactly. Glance can figure out the best way to route the data to different access points.
So it's like a smart traffic management system,
Exactly.
but for the internet within the office.
And that can minimize congestion,
Okay.
improve overall network efficiency,
Yeah.
and make sure everyone has a smooth and reliable connection.
That sounds super valuable,
It is.
especially these days when we're all so reliant on, being connected.
Absolutely. And Glance can handle both traffic load optimization and flow destination selection,
Right.
giving network managers all these tools
Yeah.
to really optimize the performance.
So I'm curious, how does Glance actually compare to, those traditional methods like NS3 simulations,
That's a great question.
like when it comes to these optimization tasks?
So the researchers actually did a bunch of experiments
Mhm.
to evaluate how well Glance performs.
What were the results?
They were impressive. Glance consistently outperformed those NS3 simulations,
Wow.
both in how accurate it was and
Yeah.
how efficient.
So it not only gives you better results, but it does it faster.
Exactly. And that speed is super important, especially for like those real-time applications
Yeah.
where you need to adapt to, changing network conditions really quickly.
So it's like having a network optimization expert on call 247,
Right.
constantly analyzing and tweaking things
Yeah.
to make sure you're getting the best performance.
That's a great way to put it.
And it's important to note that they tested Glance
Right.
in all sorts of different scenarios,
Yeah.
including wired and wireless networks.
Exactly. So it's not just for like one specific type of network.
Right. It's a versatile tool
Mm-hmm.
that can be used for lots of different network architectures.
Absolutely.
That's really encouraging.
Yeah.
It sounds like Glance has the potential to totally change the way we manage and optimize wireless networks.
I think so. Yeah.
Now, while Glance has shown it can do some amazing things
Mm-hmm.
with, these optimization tasks,
Yeah.
I'm wondering about its limitations.
Sure.
Are there situations where it might not be the best solution?
It's important to remember that no technology is perfect.
Right.
And while Glance works great in a lot of cases,
Yeah.
there are some situations where its performance might be, a little bit limited.
Like what?
So the researchers noticed that Glance could sometimes have trouble
Okay.
when you're dealing with really dynamic network topologies where
Uh-huh.
nodes are moving around a lot or constantly changing how they're connected.
So if the structure of the network is always in flux,
Yeah.
it might be hard for Glance to predict and optimize the performance accurately.
Exactly. It might need some extra help in those cases
Mhm.
to adapt to that rapidly changing environment.
It's like trying to manage traffic on a road
Yeah.
where the
yeah.
lanes and intersections are always shifting around.
Exactly. Perfect analogy.
Another potential limitation is that Glance's accuracy might go down
Okay.
if the traffic patterns are super complex
Mm-hmm.
and very different from the data it was trained on.
Right. So if the network traffic is just totally unpredictable and chaotic,
Yeah.
Glance might struggle to make accurate predictions.
Okay, so in those situations,
Yeah.
more research and development might be needed
Exactly.
to improve Glance's ability to generalize
Mm-hmm.
to those unseen traffic patterns.
That's right.
Okay, those are some important things to keep in mind.
Yeah,
But overall, it seems like Glances has shown us some pretty amazing capabilities,
absolutely.
both in predicting and optimizing network performance.
I agree. It's a big step forward
Yeah.
for wireless networking.
So where do we go from here?
Well,
What are some of the exciting possibilities for the future of, Clancy and LDTs in general?
yeah. Well, one area that's really promising is the development of even more sophisticated LDTs
Okay.
that can handle even more complex network situations.
So like pushing the boundaries of what these AI-powered network assistants can do?
Exactly. Imagine LDTs that can not only optimize traffic and routing, but also things like power consumption, security, even user experience.
It's like giving wireless networks a brain boost, allowing them to adapt and optimize themselves in real time.
Exactly. And with all the advances in AI and machine learning, I think we're going to see like a whole new era of intelligent connectivity.
That's really exciting.
It is.
But before we wrap up this deep dive,
I
want to leave our listeners with a thought-provoking question.
Go.
The research we talked about today has focused on optimizing traffic and flow destinations. But what other aspects of wireless networks could be changed by LDTs like Glance? I mean, could we use Glance to like make batteries last longer on our phones? Or create better defenses against cyber attacks? Or even like personalized network settings for each user?
Those are great questions. And the possibilities really do seem endless. You know, as researchers keep digging into what LDTs can do, I think we're going to see them applied to like a whole bunch of different challenges in wireless networking.
It feels like we're just scratching the surface here.
Yeah, I agree.
This research on Glance is just the beginning.
It is.
And what excites me most about this whole thing is like how it can actually make a difference in people's lives.
I mean, think about it. Faster, more efficient wireless networks could change everything, from healthcare to education, transportation.
We could have remote surgeries with almost no lag. Students in, underserved areas could access better online learning. Self-driving cars could talk to each other to prevent accidents.
Absolutely. It's huge.
It really is.
It's pretty inspiring to think about all the good things this technology could do. And it all starts with, research like this, what we're talking about today with Glance.
Well said.
Yeah.
And to all of our listeners out there, especially those of you working on wireless networks and AI and machine learning. I hope this deep dive has given you some new ideas. And inspired you to, see what's possible.
Keep pushing the boundaries.
Exactly. Keep exploring, keep innovating.
Keep pushing those limits.
That's it for our deep dive into Glance and the world of learnable digital twins.
Thanks
for joining us, and we'll see you next time.